Hey guys, and welcome back. I'm Mrs. Koblitz, and today we're going to be looking at solving systems with graphing versus substitution. So what you're going to notice with each one of these is that they're the same lines, okay? So I'm going to graph it, see what my solution is. I'm going to substitute and see what my solution is, and make sure that we get the same answer, and then we're going to kind of compare them. And we should definitely get the same answer. So without further ado, let's get started with number one. With our first equation here, I know that my slope is directly in front of that x, so my slope here is going to be a 1 over 1. My y-intercept is that last number there, and we write it as an ordered pair 0, 6. So I'm going to graph that line first. So I'm going to start at 0, 6, which is up 6 on the y-axis. 1, 2, 3, 4, 5, 6, right there. And then from there, I'm going to go up 1 to the right 1. I'm going to continue putting dots as far as I can, because the more dots you have on there, the more accurate your line. Alrighty. I always like to draw my lines right away, because sometimes if we have too many dots and we didn't draw our lines, it's hard to tell which ones go with which. Alrighty, here's our first line. Let's look at our second line. I'm going to do this one in a different color. So for our second line, again, our slope is right there next to the x, and our slope in this case is going to be negative 2 over 1. Our y-intercept is that last number, that constant, and we're going to write that as an ordered pair 0, negative 3. So let's go ahead and graph that next. Let me see if I can find a little bit of a darker blue. I know it's kind of hard to see. We'll start 0, negative 3, so I'm going to go down 3 from the origin and put my point. Then from there, I'm going to go down 2 to the right 1. So down 2 to the right 1. Keep doing that pattern as far as you can go. Now, since I can't go any further, I'm going to go up 2 to the left 1. And draw that line. Alrighty. Well, let's see where those two lines intersect. This point looks just about right. Let's see what that point is. So on my x-axis, which is right here, and here's my y, I need to go to the left. So I'm going to go 1, 2, 3, so negative 3. And then I'm going to have to go up from there, so 1, 2, 3, up 3. All right, there's that solution. Now let's jump over here. We learned that with substitution, you have to have one of your equations solved for a variable. And in this situation, we have both, so we're lucky. I'm going to take what this y equals and substitute it into the other equation for the y. So I'm going to have x plus 6 equals negative 2x minus 3. All right, not too bad. I'm going to add my 2x on both sides, leaving me with 3x plus 6 equals negative 3. Let's subtract 6 on both sides. So now 3x equals negative 9. And if I divide by 3, I find out that my x equals negative 3. There's half my answer. I have a prediction that my y is going to be 3, but let's find out for sure. Let me grab my black marker here so we can show the difference. I'm going to substitute in that negative 3 for the x in the first equation. So I have y equals, instead of my x, I'm going to put in negative 3 plus 6. I know negative 3 plus 6 is positive 3. And there you go. Same answer, two different ways of finding it. Not too bad. Alrighty then. There's number 1. We're going to do every other for these. So let me jump down and we'll get to number 3. Okay. Wonderful. Number 3. So I see with number 3 that I don't have either of my equations solved for y. I'm definitely going to need to do that for both in order to graph. So I'm going to start by rewriting the top equation. And I'm going to solve this for y first. So to do that, I'm going to subtract my 2x on both sides, leaving me with negative 3y equals negative 2x minus 12. Next, I still want to get this y by itself, so I have to divide by negative 3. Whenever you divide a negative by a negative, it becomes a positive, and we're going to get y equals positive 2 over 3x plus 4. So the slope of this line is going to be 2 over 3. My y-intercept, or where I should start, is going to be 0, 4. I'm going to put that on first. So 1, 2, 3, 4 from the origin. Then from there, I'm going to use my slope up 2 to the right 3. I'm going to do the reverse as well. Down 2 to the left 3. All right, let's draw our line. I always like to draw my line when I'm done with it so that when I'm done drawing my points, it really helps me to not confuse the 2 lines. All righty. Now let's look at the second equation. I'm going to do this work right over here and make sure I'm not out of the screen here if I do that. Nope, we should be good. So I have my x plus y equals 9. The only thing I would need to get rid of in order to get the y by itself is I need to subtract 1x on both sides, leaving me with y equals negative 1x plus 9. My slope is going to be negative 1 over 1, and my y-intercept is 0, 9. Let's start there. So from the origin, I'm going to count up 9. There it is. There's my starting point. Then from there, I'm going to go down 1 to the right 1. Draw my line, and we can find our ordered pair. Alrighty. I can see there's definitely one solution right here. Let's see what that point is. Remember, this is your x-axis, and this is your y. So I'm going to count to the right first. 1, 2, 3. So we have positive 3. I'll write that right here. So we have positive 3, then let's go up. 1, 2, 3, 4, 5, 6. Positive 6 is the y. All right, there's our solution. Let's check out substitution method. Well, I already solved for y in both of them. So I'm just going to choose the second one that I solved for. So right here, this equation became y equals negative 1x plus 9. I'm going to take that expression and substitute it in for y in the other equation. I'm going to grab my other marker and I can show you that work. So we have 2x minus 3 times this whole thing, which is negative 1x plus 9, equals negative 12. All right, let's distribute this negative 3. Drop down our 2x. Negative times a negative gives me a positive. Negative times a positive gives me a negative. What I see is I have like terms on this side. I'm going to combine them. Got to get rid of this 27. I'm going to add that on both sides. And lastly, we'll divide by 5 to get x equals 3. So far, so good. Now, in order to solve for my y, I'm going to substitute that 3 back in for x and solve. I'm going to use this bottom equation because it looks super easy. So instead of my x, I'm going to have that 3, then plus y equals 9. All I have to do is get rid of that 3, and y is going to equal 6. Beautiful. All right, so as you can see, graphing, we're going to find the place where the two lines intersect. That's our point. We can always plug these back in for x and y to make sure that we did it correctly. For substitution, we solve for one of the variables. We did it already for graphing. Then we substitute that in for the other equation, get a value, then take that value and substitute it into one of the other two originals, and we get our ordered pair. Did not do bad. Let's jump to number 5. Alrighty. Number 5 looks fun. I love when they do any other work for me. So let's look at number 5. For this first one, it's already solved for y, which tells me that my slope is a positive 2/1 and my y-intercept is 0, -4. I'm going to graph that right away. So I'm going to start at -4 on the y-axis, and then from there I'm going to go up 2 to the right 1. Let's graph that line. Alrighty, let's look at our second equation. We're going to need to solve that one for y as well, but the other one was solved, so we need to solve that one for y. Let's subtract our 6x on both sides. That goes away. Bring down our -3y equals -6x plus 12. We're going to divide by -3, leaving us with y equals positive 2x minus 4. So my slope is 2/1, and my y-intercept is 0, -4. I would start right here, and then go up 2/1, and then I draw my line. And what you can see is it's the exact same line. I always like to show those double arrows because I know that you guys are probably using a pencil. So this is the exact same line, which means that every single point on this line that goes forever in both directions is a solution. So our answer is infinitely many solutions. So we know when it's infinite solutions, it's only one line. But what would it look like for substitution? Well, let's find out. Y is already solved for here. I'm going to take this expression and I'm going to substitute it into the other equation for y. Let's see what happens. So we have 6x minus 3 times 2x minus 4, close that off, equals 12. I'm going to distribute this -3, giving me 6x minus 6x plus 12 equals 12. Well, I know that 6x minus 6x will cancel each other out, leaving me 12 equals 12. That is a true statement, which means infinitely many solutions because it is the exact same line. Alrighty, starting to see some differences here. Let's jump ahead to number 7 and see what we get with that one. Alrighty. For number 7, unfortunately, neither of those two are solved for y, so we're going to have to do that first. Let's start with our first equation. I'm going to rewrite that one, this guy right here. I'm going to rewrite that one right here, and let's solve for y. In order to solve for y, I'm going to subtract my 2x on both sides, leaving me with 9y equals negative 2x plus 27. Last, I need to divide by 9, leaving me with y equals negative 2/9 x plus 3. The slope of this line would be negative 2/9. The y-intercept would be 0, 3. Let's start there. There's 0, 3. Then I need to go down 2 to the right 9. And then I'm going to go up 2 to the left 9. Let's draw our line. Alrighty, so far so good. What about our second line? Right here, I'm gonna solve this one over here, to the left. So we have x, we'll do 1x minus 3y equals negative 24. I need to subtract my 1x on both sides, leaving me with negative 3y equals negative 1x minus 24. Last, I'm going to divide by negative 3 to everything, and I get y equals a positive 1/3 x plus 8. So my slope of this line is 1/3, and the y-intercept is 0, 8. Let's start there. I'm gonna go up 8 on the y-axis. Then from there, I'm gonna go up 1 to the right 3. I'm gonna go the opposite way, down 1 to the left 3. And draw our line. I can see we're going to get a one solution answer here. And let's see what that is. We got to find that ordered pair. So again, we're going to start looking at the x-axis and then the y. Here's where they intersect. So I'm going to go to the left, so that's going to be negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have negative 9. Then we need to go up 1, 2, 3, 4, 5. All right, there's my solution. Since we already solved both of these, I am going to plug in this second equation here. So I know that this guy becomes y equals 1/3 x plus 8. So I'm going to substitute this in for the y in that first equation. So let's go and see what happens. We have 2x plus 9 times 1/3 x plus 8 equals 27. All right, let's distribute this positive 9, giving me 2x plus 3x plus 72 equals 27. Then let's combine our like terms here, which would give me 5x plus 72 equals 27. Let me grab my calculator because I don't want to mess this up. I think it's 45, but let's subtract 72. That's what I thought. 5x equals negative 45, so when we divide both sides by 5, x will equal negative 9. All right, that's half of it. So far, we're right. Let's plug that back in and see what we get for the y. I'm going to plug it in to this bottom equation. So we have negative 9 minus 3y equals negative 24. If I add 9 to both sides, I get negative 3y equals negative 15. Then if I divide both sides by negative 3, I get y equals 5. Matches? Wonderful. We're good to go. All right, guys. One more to go through. We're gonna go through number 9, and then you guys can practice the evens on your own. Number 9. Once again, we don't have any solved for y, but that's okay. We'll do that first. Put my calculator down here. All right, number 9. I'm gonna solve this first one right here for y. So we have 2x minus 2y equals 14. In order to solve for y here, I'm gonna subtract 2x on both sides, leaving me with negative 2y equals negative 2x plus 14. If I divide both sides by negative 2, I get y equals 1 over 1x, I'll put that like that, minus 7. So my slope, 1 over 1. My y-intercept is 0, 7, or 0, negative 7. Let's go ahead and start there. So I'm gonna go down 7 from the origin, put my point. Then from there, I'm gonna go up 1 over 1. Up 1 to the right 1. All right, let's draw our line. All righty, first one's done. Let's look at our second one. So this second equation, I'm gonna solve right here. So we have 1x minus 1y. I'm just putting the ones in front of there. I'd like to do that. Equals 2. I'm gonna subtract 1x. Negative 1y equals negative 1x plus 2. My last step will be to divide by negative 1, leaving me with y equals 1 over 1x minus 2. So my slope is also 1 over 1, but my y-intercept is 0, negative 2. So let's start there. There's 0, negative 2, but I'm going to go up 1 over 1. What do you notice about these lines? They're the exact same what? Slope. And if they have the exact same slope, they will never intersect. You see they start at a different point. They're never going to intersect, which means you have a no solution on your hands. Let's go ahead and write that. Then right here, I'm going to write parallel lines. Alrighty. Over on the substitution side, I see the first equation that we solved is right here. I'm going to rewrite that over there so I can see it. So I have y equals, this became y equals 1x minus 7. I'm going to take that and I'm going to substitute it in for the y in the other equation. So then I have x minus, I'm going to put a little space there and we'll see why in a minute, 1x minus 7 equals 2. So there's an invisible number between those two. It's a 1, so I want to know that, I want to remember to distribute that negative 1. So I have x, negative 1 times 1 gives me negative 1. Negative 1 times negative 7 gives me a positive 7. I have a positive 1x, I have a negative 1x. They cancel each other out. 7 does not equal 2. That's how you know this is no solution. All right, guys, well, thank you so much for tuning in. I hope this helped you. Please try the evens on your own. And if you're having any trouble, just reach out to your teacher. Take care, guys. See you soon.